Okay, good afternoon, everybody. So let us start our lecture today. And today is February 23rd, right? So we are on week 7, right? So this week, and you see that we are halfway of this course. So this week we will discuss 1D array searching and sorting algorithms. Okay, so I think this will be a good topic and interesting topic. Okay, so how was your test one?
It was good.
Okay, thank you. So in our previous lecture, we discussed module 4. We discussed one-dimensional array, right? So that we discussed this array is a kind of list. Okay, what is a list? List is a kind of set. The main difference between a set and a list is that a set does not contain duplicate element, but a list may contain duplicate element. So in some languages it is called list, and some languages most of the languages it is called array. So in Python you will hear list. Okay, so array. So in general, when you do programming, array index starts with 0. So in array or a list, all the elements stay together one after another in serially. Okay, so this is why it is called a serial data structure. So these address are adjacent one after another. So in programming languages, most of the modern programming languages, array is accessed by index. The first index starts with 0 and last index is n-1. So the total element over here is n. That means n will be here 0 to 6. That will be 7. So n will be last index plus 1. Okay, so we discussed this, how to access an array and how to declare array in. Did we cover this in our last lecture or not?
No.
We did not cover. Let me see. I think we did it, right? So okay, even we did not do it. We can do it, no problem. Okay.
Well, last class was just like you're reviewing the test. I don't think you went over
Before
any of this.
that, previous.
Oh, okay.
No, we just went over part 1, module 4, part 1, not this one.
Okay, that's good. So then we can go part 2, no problem. So so in pseudocode, so that we use create keyword to declare an array. Okay, but in actual programming languages, there are some little bit different approaches in programming language to language. Okay, so in pseudocode we say create and then array name and then 5 within square bracket. This 5, that means it will have 5 elements. Okay, whenever we have create, then this 5 is not index, this 5 is length or size. Okay, so here in Java and C plus and C sharp, you may use almost same context. It is in int, and this is the symbol of array. So whenever you see a square bracket, this is a symbol of an array. Okay, so int, this is array. Actually, this square bracket is within the type. So we can say put this here with before the name of the array, or we can skip space, or in some books you may see that it is here. You may see it is here after the array name. But wherever it you see, whenever you see a square bracket, then this is a symbol of an array. An array name is my array and it's 5. Whenever it's a 5, you see the 5 new int 5, then 5 is the size. Okay, this is the creating an empty array. And but whenever you create and initialize an array in one line, we can store value within square bracket. So this is we can say int, then if we give the values immediately, we do not give the size over here. We do not give size over here. In some languages, if you give size here 5, then it will make an error. Okay, so we will keep it empty, then compiler will get the size automatically 5. There are 5 elements here. Okay, so as many elements as you put over here, the size will be set up that. Okay, and here, okay, so here we are here. So here elements are separated by comma. Each element is separated by comma. So these elements are integer element. Okay, so array type is integer. So elements must be integer. So an array contains homogeneous data. Okay, and or compatible data. An array, if your array is integer type, it cannot hold other data that is not compatible to integer. Compatible means if it is an integer, then it can hold byte or short type data. But okay, that means it cannot hold a character type or string type or decimal type value. It cannot hold. It cannot hold this one. Okay. So this is in Java and C#. Okay, but in C++, okay, in C++, you can give this way also. Okay, so you can give this way, and also actually these two lines, actually what is that called? In C++, you see that this is the different. In Java and C#, maybe I can copy side by side. This is in C++, in C# and Java. So in C# and Java, we declare like this. Okay, but in C++, we declare you can give a size. It can be fixed size, or you can give size over here as 5 or 10, whatever you see. But we see give integer type and then my array and the size. Okay, so you see that there is this variation between language to language. Okay, so be careful about this. Okay, so now how do we access elements from an array? We access elements from an array by their index. This index must be an integer value and it must be a positive value. An array cannot have a negative index. The lowest index of an array is 0. So by doing this, whatever you're doing, you are accessing from the 5th slot. Okay, 5th element. So this is the confusing part from new student, that by using 4th index 4, we are accessing the 5th element. Okay, so in your test you will get a question. If you get a question that some of you may do mistake. Okay, for instance, we say and then another thing is that create my array 50, that this line is creating an array, declaring an empty array, right? And then whenever you say my array with index 3, at index 3 put 12. Okay, so at which place this 12 will go? So the first place is 0, second place 1, then 2, and then 3. Okay, that means fourth place. Okay, so then with index 3, it accesses the fourth element. And since it is an array, so like this way it will not work. So I cannot say my array, for instance, equal to 12. It works only non-array type data. So if my variable is was like this, then this statement will work. But this is my not a single variable. Okay, so array is a bunch of variables. They have a common name. Okay, so this is a common mistake that some students do. Okay, so create my array with 5 size. The slot will be from 0 to 4, and we can say my array 0 is going to value equal to, you can say equal over here. Okay, equal 10. We can say equal 10. So in pseudocode you can give a back arrow, or you can give even equal sign, no problem. This equal sign is the assignment operator. And so whenever we access an array element with this index, we can do whatever we need, like like a regular variable. And also we can assign an array element. We can reassign an array element to a regular variable. So here second number is a regular variable, and this my array is an array variable, and with index 1, that means it is accessing the second element. Okay. And then how can we modify an element? Just put the element over here, access the element. So can anyone volunteer with me? So which element I am modifying here?
The
Which
fourth.
element? Yes, modifying the fourth element. Okay, modifying the. Do not be confused that we are modifying the third element. Okay. So how can I modify the last element of an array? I want to modify the last element. Modifying the last element. How can I modify the last element? For instance, my element size is n. So how can I modify the last element? Can anyone please tell me how can I modify the last element?
Put n instead of 3.
Here you said n. Is this one?
Yeah, I think.
No, you're not correct. You are a little bit incorrect. You're pretty close, but think about one more time. What is that? So did I tell you the last element has index n-1 always? So in an array of size n, you cannot have this. If you do that, this will give an error. It's called out of index error. Okay, be careful about this one. Okay.
Wait, so why do we do -1 again?
Yeah, the first index start with. So why do we say the second element? Same reason. Why do we say second element here? Second, right? So index with 1, right? Second element has index 1, right? So why do we set is fourth element? Why do you say it's fourth element?
Because it starts from 0.
Yeah, start from 0, right?
Yeah.
Index 3 is fourth element. So then last element will have index n minus 1. Understand? If n equal to 100, last elements will have 99, 0 to 99. Still, you understand or still you have question? Are you okay?
No.
So here, index for we have 5 elements, right? First index 0 and the last index.
It's for, yeah, I get that 0 takes place.
The first element, this is second element, third element, fourth element, fifth element. So the what will be the last element over here? This is the last element.
Ah, okay.
You understand?
Yeah.
Okay. So for any array, last element has index n minus 1. Okay. So now, if I have an array of any size, so then we can create easily find size of the array, and instead of doing this kind of individual assignment or accessing value, we can use a for loop easily. So for loop is widely used for accessing array elements. It's commonly used. That means although we know that everything we can do with for loop, we can do it with while loop, but for loop is what is commonly used for accessing array element. So what will be the effect of this code? Can anyone please tell me? So we are creating an array named my array of size 5 elements. Okay, and then for I equal to 0 to 4. Why I'm not going to 5? Because the last index will be n minus 1. Okay, so that means 4. And then I am putting my array with index I equal to 42. That means I am assigning all of the elements with value 42. Okay, so all the elements will get value 42. So one thing is that whenever an array is created, all the elements in an array stay together in a single family. Okay, these members stay together as a single family member. Okay, so you understand? Has anyone any question about this? That I'm telling all the elements will be assigned with value 42.
I have a question on the last slide. The previous
Slide,
slide.
yes, previous slide.
12. Slide 12. For the last element, does it have to be n minus 1 or the n be another letter? Or does it have to be n?
In whatever n will be an integer value, right? N will be an integer value. I'm telling n is in general.
Okay.
N can be 10 if n is a size, where n is the size of the array.
All right. Thank you.
Okay. So do you understand that what is the effect of these 3 lines? This statement will be it will first create an array, my array, and then it uses a for loop to assign all elements with same value 42. Okay, the next few slides that we discuss this line by line. I think so. Initially, when we create an array, my array, this will be my array. All elements will be for integer type. All elements will be 0. For Boolean type array, all elements will be by default value will be false. For double or float type, all elements will have default value 0.0 and so on. Okay, but for string, all elements will value null. Okay, and the for loop initially for I equal to 0, and then what will do, it will access my array index 0. That means this memory location, and then it will put 42 over here, and then 42 over here. Okay, and then it will go back to for loop, and then for I will be 1 again, and then it will assign the 1 slot, second slot, and then it does will put value 42 and so on. So you can go through these few slides. So this slide, there's a couple of slides that does almost something. Okay, you can go through this slide. Okay, has anyone any question about this? So today I got my teeth pain. So yesterday I have a dental some kind of surgery. So it's difficult for me to speak loudly. But whenever I ask you a question, please respond to me, okay? Quickly so that I can go. Okay, so I think you can go with these slides. These are same. Now, in modern programming languages, so like for most of the programming languages, there is an attribute. It is called length that can be used to find the length of an array. Okay, so in some languages it has length method or length attribute. So C++ does not have either length method or length attribute. So then you must declare a size variable and use this initialize this array. So C++ people who are taking C++ lab, please be careful, okay? And then give attentive, be attentive. So here this is the warning for C++ people. So C++ is one of the oldest programming languages. So in modern programming languages, so there are some limitation or some difficulties in older programming languages like C++ that are resolved in C# and Java. So in Java language, we have a length attribute because the length dot length, so it will get automatically length. You don't need to be worried about length. And always about look careful about here. You must give here. You see, for I equal to if you all array start with index 0 and then it ends with index there's length -1. So since it's length -1, so if you give equal sign over here, you need to give length -1. Okay, that means if you use less or equal sign, then you need to use length -1, and otherwise just less than. Okay, and in some languages there is a for each loop. Instead of for, there is a for each. That is more better, and that can be used a little bit easier way. For instance, we can see for each use a for loop. Okay, I think okay, we can do like this way. For each, I think there is a mistake over here. It should be for each. So instead of for, we can say for each is I and T. This is colon sign, that means in. Okay, in data storage, that will be another storage value, whatever you like an array. This is the array name, and it is mainly used for object type array. Okay, so whenever we it will be easy for you to understand. Okay, and Java also has and Java and C# almost same, they have for each. Okay, and but the difference is that in Java we use colon sign, and but for in C# we use in. In means this colon sign. Okay, that is the variation between Java and C# to use the for each. Okay, but C++ what use, I believe it will be for each. You can check, it should be for each. There's a mistake over here. Yes, any question? Okay, then processing an array. Okay, I have a question at this point. I need your opinion. So didn't we declare the test date ahead of time? I think for the last few weeks I was telling that
Yes.
we test, right? There will be test, there will be test. But we got some students, they said they did not know that there was a test. So our schedule said that test one here, like a few weeks ago, right? And previously, few weeks ago, that I was telling every lecture at the beginning or ending of every lecture that there is a test, right? There is a test, right?
Yes.
So that, do you have any suggestion what we can do better? Still, we got few students, they said they do not know that there is a test.
Maybe send an email.
Who is student we can email? So whenever I send an announcement, you get an email, right? How do you know see my announcement? Whenever I send an announcement in D2L, do you get an email?
No, the announcement just in D2L. You have to send an email for us to get the email.
Okay, so then I use a Teams app, right? Whenever I send a message, Teams, this morning I send a message. You got that message?
Yes.
Okay. We don't know how to so you see that there's a quiz. So this week there's no quiz. Still I got a few students, not many this semester, 2 or 3. At least 2 students, they said they did not know that there is a quiz. There are quizzes. So our slide, our schedule, course schedule, it clearly says that there is a quiz, right? There is a quiz. And if you go to D2L, it shows you on your calendar that there is a quiz. Okay.
Hi, Professor.
Yes.
Is there any way that we can review the question on the quiz?
Question on the quiz?
Yes.
Yeah, we can review. So who is quiz?
Quiz 4.
Yeah, I will do that, but let me finish. I think so. Maybe I can do next week.
Okay, thank you.
Because this week I have a lot of things to cover. I thought I covered this one, but I was behind a little bit.
Thank you.
Okay, so processing an array is just processing the regular variables. Okay, but one thing is different, that remember that an array is a name of a kind of a group of similar variables. Okay, group of similar variables with a common name. Okay, so for instance, if you know how to access a variable, then just you when you get an array, you have index. Using the index, we access the array variables, different variables. Okay, individual. So an array is not a simple data type. Okay, an array is a complex data type. So for instance, here is smallest so far. This is a single variable, but here this is an array. Okay, that means is random array is an array. So we are accessing its first element. So an array, it has multiple variables together. Okay, so this with including this index, this one works as more likely as an independent variable, but without this index it cannot be accessed. This is invalid. So for instance, this line of code, it will ask you to find the smallest element. So when we find the smallest element, initially we assume that the first element is the smallest element. Then what we do, we loop through the remaining elements. How do we loop through the remaining elements? The first element has index 0, then the second element has index 1, and the last element has index n-1. So we do the for loop starting from the second element to all the way to the last element, and if we check if any other elements, so we see the counter, we are giving this counter is changing through for loop, and we are giving counter over here. If we find any other element that is smaller than is our initial this initial smaller element, then we make that element as the smallest element, smaller element, and by doing through this loop we can find the smallest element. So initially what we say, for instance, we say that element at 0 is 42 is the smaller element. No, we know that this is not smaller, right? Visually we see that this is not smaller, but initially we'll assume that this is the smaller element. So then we will check for the second element. If the second element is smaller than this first element, then no, so we say no, we got another element that is smaller than 42. So let us make then whatever, make this one as the smaller element. And then we check for another element. No, this is not small. So we check for the next element. Yes, this element is the smaller than 17. So now we consider that we put that here. So this will be smaller element, and we go all the way. So by this way we can get the smallest element. Okay, so the next few slides, they trace that whatever I discuss here. Okay, so this for loop, using a for loop over here. So I think you can go these slides and then we will do that easily. Okay, so at this point, for instance, if we want to find the largest element instead of smallest element, what we should do? There is a little bit change in this program, and there is only a single change in this program. We can find the largest element. So this code will give you the smallest element. So how can I get the largest element? Has anyone any idea?
Switch from less than to greater than.
Yes, here is called greater than to less than.
I meant the other thing.
Yeah, it's a single change, right? So if you understand one problem, you should be able to solve another problem. Has anyone any question?
No.
Okay. Oh, I remember that quiz in quiz 4 there is some, I saw an email, there was some mistake in and maybe one or two questions. I asked them to fix it. I think you will get bonus point for that one. Okay, so okay, there is a note over here. We have found the smallest element in the array. Does computer know what? Yes, the computer that the smallest element is stored in a variable, right? And then later we access that variable, we print that variable, then we get it. It's easy. Okay. So smaller element or this minimum element is fine, same thing, right? Find the smallest element or the minimum element is same thing. Okay, this is the same thing. So this pseudocode is implemented in Java here. Okay, so you said in Java we have a.length attribute. Okay, and in C# you can write everything same except L. L is in uppercase in C#. This is Java and this is C#. Everything is same. You see that except L attribute in C#, L is in uppercase. Be careful, and then everything is same. Okay, but in C++, we're unlucky that C++ does not have the length attribute. Okay, but we can find a size. I know a technique how to find a size. I'll show you in live code, okay? And then we can use that size, okay, in order to do that. So be careful about the never use equal sign over here, okay? So if you give equal sign over here, then you need to give -1. Same thing, right? So why I'm going to do complicated? So I should give less than. Okay. So in pseudocode, okay, be careful about here. So for instance, if you create some two variables and average, okay, initially sum needs to be initialized at 0. Otherwise you may get a garbage value and then unexpected result. Okay, and for I equal to 0 to nums, I did one more line over here. Create.
I didn't get that. Could you try again?
Okay, so create nums. So maybe I can say 150 or whatever you say. Okay, so this is an array. Okay, we need to add this line. So this is the array. So this is the array. And then so Can anyone please tell me why I'm giving this code here? Why I'm using nums dot length -1? I'm giving the last index, right? Last index number is length -1, right? So don't confuse that. This minus is related to the whole thing. This is the whole thing. And we are adding sum, increasing sum. Sum equal to sum plus initial previous sum plus num I. And after the for loop, whenever we end the for loop, we find average. Average is equal to sum by length, right? Length of the array. So here we do not give n-1. So this is pseudocode, this is Java code, and this is C# code. Is a little bit different, only one different. Okay, so then L is in uppercase, but in C++ people, we need to know the size. Okay, and the size will be, you need to get ahead of size. Okay, has anyone any question so far?
What does hold the size? I mean.
B is array name.
Oh, so before that.
Yeah. Okay, has anyone any questions so far?
No.
Okay, that's good. Please review. Okay, go through the slides and then module 4 part 1. I thought I covered this last week. Okay, but today we will go through searching and sorting. So we are already halfway of searching and sorting. Okay, for instance, previously we discussed how to find the minimum element, right, or maximum element. That is a kind of searching. Searching, that means whenever you want to search for a specific element, whether this exists in an array or not. Okay, so that is called searching. So there are a number of searching algorithms. Okay, first one is called linear search algorithm. That means in the and then binary search algorithm. At least we will learn two, and there are bunch of sorting algorithm. Number one is called bubble sort, insertion sort, selection sort, merge sort, heap sort, quick sort. There are many sorting algorithms, and still computer scientists are doing a lot of research in order to develop efficient sorting algorithms. It is not done yet. Okay, so the searching algorithm are easier. Okay, to find the searching, find a specific element. At best, we need to go to check for all the elements. If my element is the last element, then we need to go all the way in to search, right? Check one by one. Okay, and there is a binary search algorithm. We will discuss this. And there, I mentioned that there are many sorting algorithms. So at least we will discuss a few things here. Okay, 3 algorithms here. Okay, there are other sorting algorithms. One is called quick sort. Okay, the name itself is called quick sort, but that is not the quickest. But we will not discuss this here in this course. Okay, first on the linear search algorithm. So the linear search algorithm, it searches all the elements one by one. Okay, so the maximum. Okay, so the average time search could be n by 2 element, where if n is the length of the element, or the maximum visit you may need n. If our expected element is the last element, then we need to do n search, right? Or n search means starting from 0 to n minus 1 index, right? And if the element, expected element, does not exist, then still we need to go to the last element before we declare that no, that element does not exist, right? So in the worst case, the maximum visit is n. So this is why you call the search, it takes big O of n minus 1. If you take your data structure course or programming algorithmic analysis course, then you will learn this. It is called big O or big omega, big O notation. Okay, that means the worst case. In the worst case, it takes n search. Okay, so linear search algorithm is a comparatively easier searching algorithm. What we do, let me go with the code. So initially we can do two ways. We can say our boolean value is, we always, this is a flag, we call it a flag. So is found equal to, initially we say false, and then we check for all the elements one by one, and if we find the element, okay, our target element, then we say is found equal to true. Okay, this is pretty simple algorithm. Algorithm means process, right? How do we find the element to check this element is, this code will check whether an element, a target element, exists in our code or not. Okay, it will not tell you at which position it exists or how many times it exists. Okay, I will go through other programs so to see in those aspects. So this is Java code, and we know that Boolean, Boolean, and in C# we use bool keyword. Okay, this is the difference between C# and Java, and in C++ we use bool and almost same code. Okay, I will go through a live code for this one, okay, in a few minutes. So but before I go through live code, has anyone any question? The searching is easier process to check whether an element exists in our list or not. Has anyone any question? I will go a live code, okay, live program, but before I go to a live code, has anyone any question? Okay, there is another searching algorithm that is called binary search algorithm. Binary search algorithm is applicable only our array is pre-sorted. Okay, then it takes comparatively less amount of time. So it's called big O log n. LG means log base 2, okay, LGN. So that means if I have 1024 elements, and if the all elements are sorted, I can do only 10 search to check whether the element exists or not. Okay, and in linear search, whereas I have to do all 1024 searches. So but binary search is easier, but its implementation is little bit difficult, and also it required that the array needs to be p-sorted. So if your array is not sorted, already not sorted, then in order to apply binary search algorithm, you need to sort that algorithm. But all sorting algorithms take longer time than searching algorithm. Sorting means arranging the elements from smaller to highest element, or from highest to low smaller element, right? Either in ascending order, that means smaller element will come first and then highest element will go all the way last, or descending order, that means the highest element will come first and the lowest element will go all the way end. So all the sorting elements, sorting algorithms take longer time than searching. So if our data is not already sorted, then binary search algorithm is not efficient to use. We should not use it. Okay. So this process, it says, for instance, if I have 32 elements, so we will in binary search. So we know that already elements are already sorted, right? So we will make split on the left side 16 element, the right side 60 element. Okay, in one chopping, in one loop, and then we will check whether elements is left side or right side. If it is in left side, then we will get rid of the right side and we will split the left side, and then we will get 8 elements. Now we will check whether this target element is greater than this side or that side. Okay, so if it is not this side, we will skip this side, we will get rid of this side, and so on. We will do this process, and we see that for 32 elements, 2 to the power 5 equal to 32, we need only 5 iterations. So after 5 iterations, I can tell whether our value exists or does not exist. So the process is not visually difficult, but the algorithm is a little bit difficult. Okay, so binary search algorithm is a little bit difficult. So I would like to give you a homework to do the binary search algorithm, to little bit study about binary search algorithm before you come to our next lecture, because hopefully in our next lecture we need to cover module, let me see the lecture. Yeah, we need to cover searching and sorting by this week. So I like to give you some homework to do some study, whatever you understand, okay, about binary search algorithm. Please do it, okay? And then I will be able to complete the 3 sorting algorithms in our next lecture. But today I want to spend about, we have 20 more minutes. We can spend with the live code for the first searching algorithm that we call linear search algorithm. Okay, linears means serial. Okay, one by one. Okay, has anyone any questions so far? So if I linear search algorithm, I have example 1 in, what is it called, in C# maybe, and C++, and I have in Java. So I have C# code. I have same program in C++, and I have same program in Java. Okay, so I will discuss in all three languages. Okay, so give attention please for the next 15 minutes. We will cover in 15 minutes. Okay, for instance, this we can find a number. Okay, so for instance, okay, so this program is written in the second module, including second module with function. Okay, we will discuss function in our next week. But for this week, you see that this is the function. How do we know that this is a function? Whenever we say parenthesis. Whenever you say parenthesis, okay, after a name, then this is a function. Okay, if you do not even understand the whole code this week, you will understand this in our next week. We will repeat it, review it in the next week when we discuss function. So find a number is a function, is a private function and static, and the return type is void. We will discuss this next time if you do not understand. And then find a number is method name, and it takes parameters. These are the parameters, two parameters. One is integer type array and another is target variable. We want to check whether this target variable exists in the array. If it exists, how many times it exists. Okay, and if it does not exist, then we will sorry, the element does not exist. Okay, so in order to do both two things we want to do. We want to check whether this exists or not. So we need a flag variable. We say flag equal to initially false. Or also, in addition to do that, what we will do, we will also count how many times that exists. So we can say count or equal to 0. So initially count equal to 0. So we will go through a loop statement to access all of the array elements. Okay, this is my array, whatever array is passed here. And if we say if my array element accessing every element by index equal to our target variable, which is logical relational operator, if it is true, then what we'll do, we will do two things. One, we will say counter your flag was initially false, then we will make it true. As long as we find it, then we get it, then we say flag equal to true. And also you will say we will increase count, then count equal to count plus 1. So initially count was 0 and flag was false. As long as we find one match, then we will see, we will do flag equal to make true, and then count will increase count. And later what we will say here, if flag not equal to false, right? That means if flag equal to true, we can write this later if other way, if flag equal to true. Okay, or in some code even we can write if flag, just simple. Okay, if flag means if true. So if condition works only with true value, right? So if we say if flag, that means if flag equal to true. Okay, then we will say, will this print element my number target is found count times. Otherwise, if flag equal to false, if there is no flag, that means flag equal to false, then we will say no, my number does not exist. Okay, so for instance, just forget about this code, forget about this code. There are multiple programs code here. Okay, for now forget about this code. Okay, we will not discuss this here. So this is my main method. In the main method, I am declaring an array, integer type array, my data, and I have these values. So we want to search whether the value 17 exists or it does not exist in the array my data. Okay, and if it exists, we will see how many times it that exists. Okay, so this is the output, only one line of output. Okay, so for instance, this one I get rid of the previous code. Okay, this one. So it will check whether 7 exists. Here is 7 exists, right? How many times 7 exists? We see 7 exists 2 times. If we run our program, for the first time, it will take a few seconds. Sorry, what is wrong? It hit it. Okay, I have internet connection. Sorry, I have to restart. Okay, if we run it, it should not take that much time. I don't know why it is taking too much time. What is this one? Okay, I'm not sure why it is not taking. Why is it taking too much time? Okay, let me go with other code in. This is in C++. I will come C++ all the way end. Okay, so let me do in Java, C# code. So Java and C# is same, almost same, pretty same. Only there is a single change that we put L is in lowercase in Java, and C# L is in uppercase, and every code is same. Okay, so let me run this program and see. Okay, it is working quickly. Why is not this program is not working? Okay, so let me explain this C# code again. Okay, so C#, this is my main method, and this is my data array, and we are checking the target variable. For instance, we can say 7. Okay, how many times 7 exists here or not? Okay, so we will see only this code. Okay, we don't see the next line. So we will discuss this when we discuss method. Okay, so I'm calling this okay, I'm calling 2 times over here. Okay, so actual code is inside now. See here. I don't need this part. Okay. Okay, I can call this one. Okay, so this program, you see that. So this is the very simple. Okay, so this actually this C sharp. I don't need to go to method. Okay, so it's declared correct. So write the code, delete code over here. So I have my flag variable here, count variable here, and I'm doing a search. If I am finding a match, then I am making the flag equal to true and count increasing the counter. So this statement here, this is equivalent to counter equal to counter plus 1 or counter plus plus, or even you say plus plus counter, it will give same thing. That here plus plus count or count plus plus. Prefix and postfix notation will give you same result. So here, since our initial counter count was 0, so if we say, we can say multiple things. Okay, you can, if we say initially my previous code when I was discussing in Java, I had like this code, if flag, right? So then that means if flag equal to true, okay, then it will work. You'll say the number target is found 7. Target number is 7. Target number is 7 is found 2 times. Okay, but now if I change my target from 7 to -7, so you see that there is no -7 over here. So that means it will say the number 7 is not found. Okay, so here the code is over here. So if you say is flag, that means it is equivalent to if flag not equal to false, not equal to false. Okay, then it will do same thing. Okay, or we can say if flag equal to true, that is same thing. Okay, and since over here we have both flag and count, so instead of using flag, I can say if count greater or equal to 1, then do this, else do this. Okay, it will do same thing. I don't need hello world. Okay, so this is the pretty simple code for linear search algorithm. Has anyone any question about linear search algorithm? In Java and C sharp, we have same code. In C sharp, we use L things in lower uppercase, but in Java, we use L in lowercase. And except that, everything is same in Java and C sharp. Has anyone any question? Okay, then we have 5 more minutes. I think we can discuss this in C++. Okay. So C++ is a little bit different. So what we do in C++, we can find C++ does not have size. Okay. C++ does not have array length attribute. So we can do a trick. We can find the size of an array. How do we find? There is a size of method C++. It is a built-in method. You will understand method in next week. Okay. So we are passing size of my data. So then how many size it will have? So 1, 2, 3, 4, 5, 6, 7, right? So 7 elements. So my data size will be 7 times each integer type has 4 byte. So 7 times 4 equal to 28. And we can divide it by 28. Size of int int is 4. Size of int will be 4. That means we can say size of 28 divided by size of my array, that will be 28, and will be 4, that means 7. Then we will get size equal to 7. And then we are checking whether number 7 exists in this array or not. Okay, we are calling the find a number method. In our next lecture you will understand what is method, how does it work. But for now, let us only see this code, and if we run this code, you will see number 7 is found 2 times. So what is my code? Find a number. So this code is same thing already. Okay, same thing. So I could copy this code from here to here. If you don't understand method now, for instance, then I can say I need target, right? Target equal to 7, we say. Okay. So then in that case, I need my data. Okay. You see same code, exactly same code in C++, but C++ you need to do this on extra line to find the size. We got the size equal to 7. Even if now if we add one more element, okay, again one more 7, then we should find 7 is found 3 times, right? And the size will be 8. The array size is 8 and 7 is found 3 times. So I have this code, complete code. Please do some practice about this code, okay? Before we come to next lecture. So at this time, I think after test 1, everybody is familiar with how to write code in all 3 languages. So this will be a good starting point to practice programming. Now at this point, you are able to start running on the field of computer programming, right? So now it is your call. Okay, as fast as you will run in the field of computer programming, you will be skilled. Okay, so I think whenever we discuss method next week, discuss method, then you will get more interest in programming. Then you will see that you are able to write some code, an innovative code. Okay. Has anyone any question?
Yeah, Professor, when will our test be graded?
Test will be graded in 2 or 3 weeks, maybe 2 weeks. After 2 weeks, we have a break.
Okay,
Right?
thank you.
So 2 weeks should be fine. We will be grading in 2 weeks. Maybe I will be grading 1 questions across all section, 1 or 2 questions then. And then we have many students, you know, we have more than 1,000 students. So its grading is time consuming.
I have a question. Will we ever have like a question from the first test in our second test?
No, second test we will get different modules. In the second test, what we will cover? Second test we will get module 1 to 5. So you will get some common thing. Okay, maybe for loop and then while loop. We need to use those in second test. Okay, oh, second 1 to 5, right? You will get very simple, some simple things, some common things that are needed for other. But in second test, mainly you will get questions from repetition, array, repetition array, and searching and sorting. Second test, module 1 to 5. So whatever I discuss in today's lecture, you will get some question, okay?
Okay.
Okay, has anyone any question? So how was the test question? Was good? Good enough? I think we should have some challenge questions so that we want to evaluate your creativity, right? We need to do some practice. Okay, thank you so much, everybody. I'm getting pains. So. And yeah, whenever we said you will get your test back, you will be able to download your graded text from the GradeScope, and you will be able to see what you mistake. Okay.